All right, so we are in Algebra 2. Today's date is Wednesday, April 24th, 2019. All right, 8-5, solving exponential equations with logarithms. So this is still based on that last standard, use properties of logarithms, but now we're using them to actually solve things. And this is where we're starting to actually be useful. Why are logs useful? This is why. But before we get to that, let's review two rules of logarithms and what happens if I don't talk about the base. What is the base actually? So, oh man, cards. I always forget to pass out the cards. Who can help me do that real quick? James. I think that's 8. And then Chris, you can just put him in here already. Log base b of m to the power of n. This is the power rule. Everyone should be raising their hand. If you're not raising your hand, I assume that your self-evaluation on this standard is a 2 or below. What do I do with this n? Something special happens with that n. Gio knows. Eva knows. Who else knows? Andrea knows. James knows. 3 ladies over here don't know? All right, Gio. This is Gio's rule, by the way. So, Gio, you should definitely know it.
So, n log base, base b.
There it is. This power comes down in front. It's saying that this power came down in front and got multiplied. So that's Gio's rule. It's called the power rule. You need to know it. You need to love it. Think about it before you go to bed. There's my 3D printer. There's Algebra 2. And there is Gio. Right there. All right. So from there, log base b of b. I need someone to read this as a what power function and explain why they got the answer that they did. What power does this need to be raised to get to this? And then the answer is what? It's going back all the way to 8-1 where I taught you about the what power function. Not a one of us? That means our first standard that we talked about is probably a 2 or a 1, not a 3 or a 4, I'm guessing. Anyone want to take a shot at it? Gio's waving his hand, kinda. Go for it, Gio.
So you have to, how do you explain this?
What power does...
is power b, right? No?
Okay. So we're saying that this thing raised to what power gives you this thing, right?
B.
And you're not quite there, but I will give you XP because you were brave enough to come for it, and I always love it when people try. Eva. The answer is 1. Can you repeat the what power? How do I say this as a what power function? What power does something need to be raised to? Can you say it all as a sentence? The answer is 1. Yes. B to what power is B? B to the 1 power is B. All right. Eva got 1. Andrea and Fiona knew what they were talking about. All right. So, and this is kind of the key thing. It's not one of our rules, but I was hoping that it would be kind of straightforward, but the fact that not very many people were able to do this means it's not that straightforward. But if I have this base and this base, well, I guess it's technically not a base. If these two numbers are the same, they cancel each other. So you're left with just 1. All right. And then log of x. If I don't have a power or a base, I assume it is what? Fiona. Yep. So this is going to be rewritten as log base 10 of x. Thank you, Fiona. And what about this relatively unknown one? We haven't really been using him, but we will be using him today. If I say the natural log of x, ln of x, that assumes it's log base what? It's a letter. Log base what of x? What goes down here? Andrea. It is E. E. E is Euler's number, Euler's constant, whatever you want to call it. E is very similar to pi if you don't know about E. I call E the speed limit of interest, among other names. It has a ton of cool properties, but generally we just want to think of it as a number like pi, 2.7182818, blah, 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 blah. It goes on and on forever and ever like pi. In my opinion, it's kind of a cooler number than pi. I don't know why everyone always tries to remember digits of pi. Phi is way cooler. E is also pretty cool. There's a bunch of constants that just go on and on forever that are kind of cool in the math community, and this is one of them. All right. So natural log is log base E. Okay. Let's come down here to our strategy. First, we need to, and I guess this strategy here is applying to like example 1, example 2, example 3 here on the back. What do we need to isolate first? And if you're kind of hesitating on how to figure this out, I'm isolating because I'm trying to get to something in Pemdas. I'm looking at Pemdas, get rid of the addition and subtraction, get rid of the multiplication and division to get to the what? Hello, Miss Sasson. I don't know. All right, so anyone want to take a guess? This is kind of hard. I can give it to us if no one wants to say again. Exponent is one of these.
Okay, there you go.
I'll write it here. Exponent. So if I have, I don't know how to spell exponent apparently. So if I have something like 2 to the power of x, x is the exponent. What do I call this thing? Eva. Coefficient is the number when I have an x not in the exponent. This would be the coefficient. Good guess. I'm still giving you XP. But what is it called? Someone else. And Eva, you can try it again. Starts with a B, 4 letters. Andrea?
No, wait, base.
There it is. Drop the base. Psh. Yeah. So we're going to isolate that base and the exponent because that, in terms of solving PEMDAS, I'm looking at PEMDAS, that's the final rung that I'm going to be doing. So once I get this thing, and I'll kind of underline what I'm going to be doing here, this 10 to the power of 3x, that's the base, that's the exponent. I'm going to get rid of 2, get rid of negative 1 somehow. Once I have 10 to the power of 3x, then what am I going to do to both sides? I'm going to take the what of both sides? It's a thing we're studying this unit. What are we studying this unit, class?
The what? The what? I'm not studying that.
James, go for it again. It's 3 letters. Starts with an L. It's when you cut a tree and it turns into...
Log.
There it is. You take the log of both sides. Thank you, James. We were studying logarithms since 8-1 and how logarithms are the inverse of exponents. So we're going to take the log of both sides. All right, and then I'm going to give you this word. We're the base. The base of the exponent and the base of the log are the same. So we'll be seeing what that looks like in a problem, but that's our general strategy. So let's come down here and skip to example 1. First, I need to isolate the base and the exponent. I need to isolate these, so let's get rid of everything else. Again, if you don't want to think about step 1, you can cross it out and just be thinking of PEMDAS. Do a reverse PEMDAS. So first, what am I going to get rid of? The addition, subtraction, multiplication, or division?
Multiplication. No, subtracting.
Subtraction, because that's the, I mean, everyone look up at the wall. I'm pointing for a reason.
Oh, I didn't even
You
know.
look at PEMDAS, it's up on the wall. Start from the bottom first. Addition and subtraction, A and S. Get rid of those things first. Then go to the next level. Get rid of multiplication and division. So, yes, we're going to get rid of this -1 by doing what to both sides? Shout it out.
Adding 1 to both
Yeah,
sides.
that's right. Add 1 to both sides. We'll just give you all, except for Chris. Sorry, Chris. We'll give you all 100 XP. Yes, add 1 to both sides. And I'm left with 2 times 10 to the power of 3x is equal to 26. Now what do I do? What do I do to both sides?
Oh, I didn't know where you got the 2 for a second. I was like, what the heck? Divide by 2.
Divide by 2. Let's switch to a different color here for the next step. Divide both sides by 2, divide both sides by 2, and I'm now left with 10 to the power of 3x is equal to 13. Andrea was our main participator there.
Oh, I was thinking about it in my mind.
That's good. That's what I want. All right. 10 to the power of 3x is equal to 13. And then this is the new stuff. This is step 2 now. Now I'm going to do what to both sides on step 2? Just read off step 2, someone.
Take the log of both sides where the base of the exponent and the base of the log are the same.
Okay, so I'm going to do log base what, Eva? Log base 10, because I want to make sure that these two numbers match up. Log base 10 of this side, and I'm going to move my 13 with technology. Sorry about that. I should have given us some room. And I'm also going to take log base 10 of this side. I'm taking the log base 10 of both sides, or I guess I'm doing that so that I can get this 3x coming down in front. That's called Geo's power rule. And then this 10 and 10 will cancel each other out. Log base 10 of 10 is 1 because 10 to what power is 10? 1. Yeah. All right, so this very next line, and I think I deserve to give Eva some XP because she read off step 2.
Yep.
I'm going to use the power rule. The power rule states that this 3x comes down in front. So it's going to be 3x. And if you want to write this, you can, but you can skip this step from here on out because you know what's left over, I'll write this in a different color, is log base 10 of 10. We know that log base 10 of 10, go away. This whole thing kind of cancels out. You can just cross it off right now or not even write it. We don't need it because log base 10 of 10 is 1. 1 times 3x is just 3x. But on the right-hand side, I still have log of 13. Again, I'm dropping the base because, as I said, up here, I don't need the base if it's just log of base 10. So dropping the base, just like your youngins' music, log of 13. I shouldn't say youngins, I listen to bass drops also. All right, so coming back up here, we're almost done. I now have 3x is equal to log of 13. I need to do what to both sides to isolate for x? There it is. James has it. Divide both sides by 3. And my final answer now is x is equal to, and then it's log of 13 divided by 3. Log of 13 divided by 3. That is my final answer. Sometimes Khan Academy, I think most times Khan Academy, will ask you to approximate that. What does this guy, what is it about? Is it 2? Is it 10? We'll say x is approximated by, and then we'll actually type this in on our calculator. We can say log of 13 divided by 3 is 0.371. 0.371. Done.
Yeah.
So easy.
It's really cool because last time the only way that we could solve for exponents up here, and let me erase this guy. The only way that we could get rid of exponents was by setting things equal to each other with the same base. 10 to the 3x equals 10 to the 2 or something like that, yeah.
Fiona has a question.
Oh, sorry, Fiona. Can you wait until after the lesson? Okay. So before we had to have the same base equal the same base, but now we have logarithms. The whole point of logarithms, the reason that we need them, is they solve exponents, since they are the inverse operation of exponents. Let's come down here to example 2. Someone help me out with step 1. I don't know what I'm doing.
17. I don't know.
Add 17.
No, don't add 17. Subtract 17.
Subtract 17.
Don't listen to me.
And I get negative 3 times e to the power of 2t is equal to negative 20. Ugh, gross. It's going to be a weird fraction, but that's what happens quite a bit. I don't know who should get XP. I'm just going to give you all XP. Sorry, Chris.
What?
Because Gio said it kind of wrong and everyone else kind of jumped in to help him out.
Good job, everybody.
So everyone gets XP. I feel like Oprah. All right, so what do I do next? Quiet raised hand, quiet raised hand. What do I do next?
Divide both.
Quiet raised hand, Gio. Yes, James.
Divide
Both sides by -3.
Divide both sides by -3 as James just instructed. And we're going to have a fraction over here, but that is okay. Don't be afraid. I will be here for you. Now we got rid of that -3, and I'm left with e to the power of 2t is equal to this ugly fraction, and I'm going to simplify a little bit. 20 divided by 3. Negative divided by negative is a positive. Thank you, James.
Wait, what did you do?
All I did was divide both sides by -3 as James told me. So I left it as 20 divided by 3, 20 divided by 3. That -3 in front of the e to the 2t is now gone.
Okay. I got you.
Good. Good questions. I always love questions. All right. Questions up to this point, Fiona?
No.
You ready for the next step?
Yeah.
Go for it, Fiona.
Do I do the L, N?
Oh, yes, you do the ln of both sides. And again, I forgot to give myself
I have a
space.
question.
What's your question?
How do we get there?
How do we get to this step?
Yes, where do we get the ln? And why do we do that?
Fiona, if you could jump in.
It's just like doing the log because it's like an E.
Fiona, get your shoes off the table. But yes, you have it 100% correct. So what Fiona's really saying here is do log base E. Since I have E here, do log base E of both sides. Log base E. But Fiona also knew that log base E is the same thing as ln of x. So she went ahead and said the log base E is still mathematically correct, but the cool little shortcutty way is to not say log base E, but to say natural log. Natural log. So I'll do natural log on this side, log base E on this side, to let you know this is the same thing. We're taking log base E, or we're taking the natural log of both sides. And I'll also put here on the side, just in case you want, log base E is equal to natural log. And I do cursive L's just in case something happens. Sometimes my ln looks like 10 if I go too fast. All right, I've taken log base E of the left-hand side from Fiona's last step. What am I left with on the left-hand side with a quiet raised hand? Eva. 2t. Yeah, everything cancels out. Chung, chung, chung. That all cancels out, and I'm only left with 2t. And then on the right-hand side, I can't do anything. That's still natural log of 20 over 3. Almost, almost. So close. We need t, not just 2t. We need t. So, Gio, I'm going to do what then?
Divide both sides by t. I mean 2.
Yes. And as a philosophical question, why can we never, well, I just shouldn't say never. Why can we usually never divide by a variable? That's part of it. I'll give you half credit, Fiona. What is the what could I possibly be dividing by now which would make it a swear word? Yeah, if it's 0, then you have committed a sin against your math gods. You can never divide by a variable unless you have somehow said, hey, that variable, don't worry about it, it's not 0. Or maybe you have some inequality. Inequalities switch whenever you multiply or divide by a negative. So maybe I'm dividing by a negative variable and I have to switch the inequality. That could also be a potential hazard. So generally speaking, we don't divide by variables. It is a bad math practice. Those 2's are gone. My t is equal to the natural log of 20 divided by 3. And then all of that over 2. Again, Khan Academy loves approximating that. I will do that for you nice and quick. The natural log, ln of 20 divided by 3 is 1.897. But I'm also going to divide that thing by 2, and I get 0.949. 0.949. And by the way, I haven't been explicitly stating this, but I am rounding to the nearest thousandth. It goes 10th, 100th, 1000th, so that means 3 decimal places.
Yo, the next one
3
is
decimal.
Like
All right, I'm waiting here until I see everyone stop writing. James just finished. All right, we are on to example number 3. This is the last type of problem that I can throw you. I need to solve for W. And it's basically the same thing, just a slight twist because it's not 10, it's not E, it's a random 3 now. So, what am I going to do? First, I'm going to James. Careful, 15 is right now being multiplied. So the opposite of multiply. Yeah. And I always say opposite, but if I was being very technically correct, I would say the inverse operation. Yeah, so the inverse operation of multiply is divide by what, James? There it is. Divide both sides by negative 15. That's James's step. And those 15s should cancel out. I'm left with this 3 to the power of 4w over 5. That is equal to, what is 60, or negative 60 divided by negative 15? How many people know this? Gio?
4.
It is indeed 4. Thank you, Gio.
Just making sure.
All right. Finally. Well, I guess not finally. Fiona, what's up? Yeah, go fast. What's up? Oh, you ready to do the next step? Playing with your hair? Don't want to participate? Don't know what you want. What do you want from me? All right, what do we do next? It was Fiona. Okay, yeah, go for it, Fiona.
Can we do log base 3 on both sides?
We are indeed. Oh, I should have given it to someone else because you've been doing them all from this point, haven't you? We're doing log base 3 of both sides. Log base 3 of both sides. And Fiona, can you explain why you did log base 3 and not log base, I don't know, 7 or something? Okay, so they matched up and they'll get rid of each other. Thank you. Fiona is still that level 7 mage, getting really close to that level 8 mage. And I need someone new-ish to tell me what to write as my new line. I've heard a lot from Fiona. I've basically heard a lot from everyone but Stego. Stego, you want to do this line?
Not really.
What if I beg you to do it?
That's okay.
Okay. I'll let Stego choose who to call on then. Raise your hand. What's the next line?
Okay, I see. I'll take. So it's 4W divided by 5 equals log of 3.
Log base 3, right?
Yeah. 4.
Yeah, log base 3 of 4. So say it one more time, Gio.
Log base 3 of 4.
Nice. Thank you,
I should get good. That was a hard problem.
Gio. Again, whenever you have log base 3 of 3, those guys all cancel out. You go chunk, chunk, chunk. Those are all gone. You're just left with that 4W over 5. And not in a power because of the power rule, which this gets brought down in front. All right. And I'm just going to finish this off for you guys. I'm going to multiply both sides by 5, divide both sides by 4, and I'm left with W is equal to 5/4 of log base 3 of 4. I will also approximate that for you guys.
Wait.
Whoa, 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 whoa.
Uh-huh. What?
So you just
Oh man, Mr. Sindel went too fast. Let's back up.
no, you didn't.
Let's back up. I was doing 2 steps at once, but I will do 1 step at once. I'm going to multiply both sides by 5. And by doing that, those 5's cancel out. I'm left with a 4W is equal to 5 log base 3 of 4. And then from there, I need to manipulate this guy by dividing both sides by 4. Let's switch to green. I haven't used green in a while. Divide by 4, divide by 4, and the 4's cancel out, and I'm left with 5 log base 3 of 4. All of that divided by 4. Which is the same thing as I wrote before, just more in a giant
Wait,
fractional form.
Can 4 and that 4 cancel out?
Great question. What does someone else think?
No, alright.
I want to answer.
The answer is no. It's kind of like a trig function where it's trapped inside. This is log of, or log base 3 of 4, so this 4 and 4 cannot cancel out. This is an important distinction to make. And then I need to approximate that. Uh-oh. Approximating log base 3 of 4? How am I going to do that?
Put in the calculator.
My calculator, well, some calculators don't have a log base 3. Most of them have just a log base 10. Say it again. Desmos does do log base 3. If you don't know how to do this, that's a problem. You need to learn how to do it because that's one of our standards, being able to manipulate logarithms, use the logarithm properties. In fact, that's the standard that we're currently on, use the properties of logarithms. So if you don't know how to do this, practice it. If you feel like you're already a 4 out of 4 for the change of base formula, then you can use Desmos. But this thing, I'm going to rewrite it now, can be rewritten as 5/4, so there's the 5, there's the 4, 5/4 times, and then change of base formula. Can someone help me do this? Log of what on the top?
4.
Log of what on the bottom?
Log of 3.
There it is. Therefore, W is approximately, here we go, it's going to be 5 divided by 4 times a log of 4 divided by log of 3, and that's about 1.577. So those are our 2 answers. Don't know why I randomly circled that. Again, you can enter log base 3 of 4 on your phones and on your Desmos calculator if you want. I'll show you how to do that really quickly if you know what you're doing. It seemed like most people didn't know what they're doing, so I'll probably leave that up to you guys to decide. But if I go to my calculator, which is desmos.com/scientific, if I do log base 3, oh, this one doesn't work. You have to go to the original, don't I? Yeah, for example, log base 3 of 4 doesn't work on here. It says it doesn't support that function. But if I go to desmos.com/calculator, which is the graphing calculator, it does support that. So if I do log base 3 of 4, it will tell me that's 1.261. And again, I had to multiply that by 5/4, so times 5/4, and I get 1.577, which is what I found right there. So you can check your work on the Desmos calculator, but you should know that this is the same, that log base 3 of 4 is equivalent to log of 4 divided by log of 3 using the change of base formula. Notice that they're the same number. All right, I want to know a fist of 5. How well do you think you can do these problems on your own? I see a 4, a 5, a 3, 3, a 5, 4, James, 3, Teflon, probably less because you missed part of the lesson, 5 from Fiona. All right, so I would say about an average of 4, which is pretty good. All right, so there are 2 homework assignments on Khan Academy, one with base E and base 10, the other with rando bases like base 3.